Hello, everybody. Welcome to our group meeting. Today we also have, we have several students who are about to start their research project. So, yeah, maybe we wait a minute or two if more people will join. Are there any questions, anything you want to ask now, any comments?
Good morning.
Hello.
I am just a student of academia program.
Yes.
Last year I completed the machine learning D course. So
Yes.
I think like the project work will be like quite similar. So is it okay?
Yes. So the project that you now do should be, of course, different from what you submitted last year.
I saw like the links in GitHub, like the description of the project work. So yeah, the structure of the project is like the same. So I was wondering, like,
Yes.
is it okay? Yeah. Okay. Thank you.
Sure. So maybe I share my screen with the practicalities. Yeah, so as I said in the email, the research project will follow the outline basically of a master thesis work. So you could think about it as a small scale master thesis project. You might actually use this research project to develop your master thesis or PhD thesis or work topic. Yeah, in general, you're free. So most of you who choose the generic applied machine learning topic, you are free to pick whatever application you have in mind and model it as a machine learning problem. So here maybe use my whiteboard. So the start of the machine learning project is that you are clear about what are the data points in your application. What real life aspect or research aspect or any aspect that you could think of would you like to model as data points? And these data points are characterized by features. So what do you know about the data points? And then you have labels. So what would you like to predict? About the data points. So are there already any ideas? Let's use this already for discussing ideas.
I mean, I have some ideas of. I think I've had some ideas before already about taking some data from a video game, basically like some positional data of different players of an online game, and then making predictions about either movement vectors or positions based on. Based on, I'm not sure if like to apply game state into it as well, but could just like kind of take the basically positional points and then apply some sort of logic or just something along those. That could be the data anyway.
Very good, very good. So let's continue here. So the first question, maybe the first and most important question of any machine learning gig is that you think about what are the data points. So is a data point here, in your case, is it a video game? Or is a data point an instance of a video game? So a video game session.
I guess in here it would be a single instance of a single game. So like one game, one match.
A match, yes. So a data point would be a match here.
Or yeah, well, let's go with it.
Yeah, then of course you could now use different machine learning models or formulations. Do you consider all matches from the same game? So everybody is playing Tetris, or can the matches be from different games? Yeah, but this is up to you then. We don't, and this might be the meat
Sure.
of the research project, thinking about this and writing it down in the report. So this might be the more important thing, and not using differential equations to model gradient descent of deep neural networks or such things. Could also be, but in my opinion, in applied machine learning, the key question, the most important question is, what are the data points? So let's say it's a match. Then what would be the features? So what do you read in easily? For what properties you don't need machine learning to find out? So all the statistics, the positions you can easily read out of a match using some API, I guess.
Yeah, exactly.
Yeah. So positions of players.
Positions of players and like score during like that position. Yeah.
Okay, what would be the quantity of interest? So what do you want to ultimately predict using machine learning?
The next state, I guess.
Okay, the label would be predict next.
Or like the state within like a given amount of time steps.
Yeah, okay, forecasting.
Yeah.
Very good. So next question would then be, where do you get data from? So what is the data source?
Either getting lucky with a node-like data set that might exist, or then generating a bunch of data by myself.
Yeah. So this is also something you must clearly describe in the report. Okay, yeah, once you have it, so once you have acquired some data, you read it in using some Python library, pandas or whatever, or I don't care what software you want to use, by the way. This is completely up to you. You then fit the model. So you could fit a linear model, like do linear regression. And yeah, after you fit it on the training data, you should validate it somewhere. So then you have, you could split the data that you have into training and validation set. So after you fit it, you compute the validation error on a validation set, which has not been used for the fitting. And yeah, then you compare, then you diagnose, you compare the validation error with the training error. With the training error, and based on this comparison, so this comparison I also want to see discussed in the report. This is for me some of the most important contents of the report, the discussion and comparison of validation error and training error, and how you use this comparison to choose a different model. So if the validation error is very high, but the training error is small, this might point at overfitting. So you have used maybe a very powerful deep neural network, which can easily fit the few training data points. So the training error can be very small, 0, but the validation error is large. So you must somehow balance this. And how do you balance it? Using, for example, a smaller neural network or a simpler model, a linear regression model, or using regularization techniques. And I want in this project, there should be at least one cycle of this whole process. So you pick first a first guess for your machine learning model, whatever you like most. You could start with a linear regression model. You train it, you compute validation error, and then based on validation and training error, you say, maybe it would be a good idea to now try deep neural networks. or decision trees or something else. And you can repeat this cycle as often as you want, but for the report, I would say at least once, so that in the end I see in your report at least 2 different machine learning methods. Okay, the timeline is completely up to you. So I will not push you for deadlines. You should know when you want the grade. So when you need the grade, you send in the report. And the report should be in the form of the project report that we used for a previous course that I taught. It's now taught by somebody else, by the way. So I'm not teaching this course C3240 anymore, but when I taught it, we used a machine learning project, and we had this project report. Okay, so here, now this is the peer review. So yeah, we will also use peer review, but first to show you the outline. Yeah, you should have an introduction where you explain the setting. So for example, what you now explained, the gaming background. This should be mentioned or explained briefly in the introduction. Then how you formulate it as a machine learning problem. So what are the data points? What do you use as features? What do you want to predict? This should be explained here in the problem formulation. Next section should cover the methods, where you should provide more details about the data set. So how many data points? Also, if some pre-processing data cleaning has been applied. You can also explain here the feature selection process. So why did you choose this specific properties of a data point and not others? Yeah, also what loss function you have used to train the model. In linear regression, we use the squared error loss, but there might be other loss functions that are more useful. So you should really explain your journey or document your machine learning work. Yeah, then there should be a section about the results where, as I said, you should clearly, explicitly discuss and compare the training and validation errors obtained by any machine learning method that you applied. And based on this comparison, I would like to see some justification. Which method seems to be better, or which one did you use? Would you suggest to use in the end? Yeah, and then a summary or conclusion section where you briefly comment on if you think the problem is solved. So you have now a match predictor, and you think that it's basically not possible to do it better. So you have solved the problem. Or if you have any ideas what could be made better, or what are the limitations of your current approach. For example, the limitation could be you just have not the means to collect more training data. So you would consider you need 10 times more training data, but you just don't have the resources. Okay, and then, yeah, I would like to also see an appendix which contains all the material that is required to reproduce your result. Could be a Python notebook, or could be a detailed description where to find which model and which data set that you have used in this research project. Okay, so that was the fast overview of the research project. Are there any questions from your side?
There's in the chat, and I could ask it as well about the 10 credit, what applies to make this into 10 credit submission.
So this basic variant, I would say, is worth 5 credits. So you work out your project, you submit the report, we grade it. And if you want to go for the 10 credits, you also require to do peer review. So you have to fill out this peer review sheets for several other reports. The precise number of how many peer reviews you have to do is still to be decided, but you then have to grade also others. And the peer review should include justifications. So it's not enough if you, for example, when we have a review questions, is the title suitable, and you just say good title or you say bad title. So what we then evaluate is how you justify your review answers or your peer review. So this needs to be justified. And there goes some work in, which should be worth 5 extra credits to get the 10 credits for the project course.
If we do the 5 credits, so is it mandatory to track your hours, or is it just you do the project, you make the report, you send it, and it's the 5 credits, and no hourly kind of schedule needs to be done or anything like that?
Yeah, I will not look up the time schedule recordings of you, for sure not. And this is up to you. We, or in particular me, I have taught some machine learning courses which included projects and which were worth 5 credits. So I have some feeling how much work went into a project report, and this then also reflects to the grade. Okay, then another question. So will our project be graded by other students or ultimately by you? Ultimately, it's by me. So I'm the final authority. Oh, I don't know. No, actually, the final authority is Jorma Laaksonen. But Jorma Laaksonen will heavily rely on my opinion. So de facto, I'm the ultimate grader. Any other questions? For the 10 credit version, how many peer reviews is required? I would say between 3 and 5. I'm not sure yet.
I guess there is a deadline for the peer review. I mean,
yes, so yeah, maybe at some point we need then to agree who wants to go for the 10 credit version, and we coordinate the peer review. So this should be in a coordinated fashion at the same time. Yeah.
I guess we'll use, for coordinating stuff like that, we'll use perhaps Slack mainly, but just wondering, like, if everyone is in Slack already.
Yes. Is there anybody really opposing Slack? So is there anybody who doesn't want to use Slack for casual communication? Officially, I think it's not allowed at all. So it's just my offer. Official channel is email. So anything officially, like deadlines for peer review or peer grading, will also be announced by email, of course. Yeah, roughly speaking, how many of you consider now to go for the 10 credit variant? You can raise your hand in the, let's see, 2, 3, 4. Yeah, not too many. Yeah. So this should then be not a big challenge from an organization point of view. Yeah. Okay. Yeah, then we will decide in a timely fashion about the deadline. You also expressed wishes for when you want to finish the course, so we will also take this into account. Some of you have a more urgent schedule, some of you less urgent, so we will also take this into account.
Do you think it's possible to get like feedback on the project at some point? Like, do you have time for that or so?
Yes, good question. So the idea would be that in the meetings like today, so you will now, I will also add you to the mailing list for our group meetings, which are every week at 10 on Tuesday. So actually what I now use is I use our group meetings now for this intro. So you have a chance to ask questions there, to present some things, some findings, and get feedback here. Via Slack, you get feedback. I'm not able to offer you weekly one-on-one meetings to give you feedback. This is not possible even for the master students that I supervise due to the amount. But for this, we have these weekly meetings on Tuesday. So you are very welcome. There's no need to join them. So it's up to you. But if you want to show others what you did, so now we have a good crowd here of 17 people. So this would be a great opportunity to get feedback. Also from me, of course. Yeah, but I also try to answer emails. So if you have a specific question, if you're stuck somewhere, then do not hesitate to send me an email. But maybe the lower threshold ways would be just stop by these meetings on Tuesdays or use Slack. Very good. Any other questions? Yeah, as a disclaimer, as you might also see, I record these meetings, but I keep it private unless I get explicit permission of everyone individually. So I ask each one of you individually who is shown in these recordings if I want to share it on Slack or on my YouTube channel. So no worries about this. And you have full control about your recording. Okay. If there are no other questions at this point, let me check. Yeah, or maybe I quickly also ask you to introduce yourself. So you is a postdoc in our group, and she kindly promised to help me with the supervision. So you might also ask you if you have specific questions.
Yes. Hey, everyone. I'm a postdoc in Alex Group. Yes, you can ask any relevant questions about the project.
Yeah. So you is also a veteran, very experienced with supervising machine learning projects. Okay, so then feel free, if you joined this info session for the research projects, feel free to stay, join the meeting further on, but you can also now leave if you want. We will now continue with our group business. Yeah, is there anybody who wants to give an update about their research work?
I wish I had actually done something that I like, but yeah, hi, Milmari. But I do have this idea that I basically shared there. I've done another project like related to computer vision on that, so that I might be able to use for collecting data, which because like I said, for in the specific application that I have in mind in a specific game, there's probably ways to get it through some APIs or at least memory reading, but I guess I'll be starting with that, but I don't have any like real work behind this yet. Looking forward to get something for next week though. It would be nice.
Okay, yeah, would be happy to hear more about it. Feel free to join us any week you wish.
Yeah, Alex, me and Henry, we had this, we were thinking of this idea for the project, and we had this idea of because we have these programmable LEDs that we were thinking of. It would be fun to use, and one idea we had was to kind of make them kind of sync to music better. So make them kind of when they kind of hear the music and then kind of flash in a way that's like suitable for the style of music, or like if there's a beat coming up or like a drop or something like that, and they'll like be, you know, the effects are kind of differentiating according to the music. And yeah, this was kind of our idea. Of course, now we have to think about what are the actual data points, what is the labels, and kind of how do we make this a machine learning problem is of course one thing we have to now think about. But I don't know, like if you like just this is our like initial idea that we'll see how it goes. But yeah,
very cool idea. So what comes to my mind, of course, and this again, this is always design choices. The design choices are hard, interesting, exciting sometimes, but for example, here a design choice is a data point, a song. So you want to learn for a song the best lightning strategy. But there are also, of course, cover versions of a song. So a song is never played the same, even by the same artists. Like a Bob Dylan song, I guess he always performs it differently. So another choice of a data point could be a recording of an audio. So the raw audio that you hear, and then it's a signal processing problem. Then you just, the data point would be a 20-second stretch of a recording that you get via a microphone, like on your smartphone.
Yeah.
And from this 20 seconds recording, you want to predict the best rhythm for a lead. And what a challenge with this second choice is, how do you get the loss? How do you define the loss function? How do you know if the prediction was good?
Yeah.
I mean, the ultimate goal is to make people dance maybe, or get a good feeling, a good vibe. But how do you measure the vibe?
Yeah, it's very subjective. Like there is what,
I mean, what you could do is you could place such buttons. Yeah, did you like it green or did you not like it red? Like you have in cafeterias to get feedback.
Yeah.
But maybe
and we also basically we can listen to it, see how it goes, but like we cannot get the very big data set by just like manually listening to how it is. And
Okay. So I have an idea of one. What if you have a button that that both records the audio that's playing, and then you push it at times when you feel the beat is going and like that, and then you go out on the club and you collect 8 hours of beat data with that
Yeah, sure.
But I was just thinking another way could be to observe how the person is moving. So from the video recording of the person, if the person starts to shake or go with the vibe, then you know, okay, this worked.
Yeah.
But very interesting.
Yeah, it's like we feel like the scope could blow up instantly if we try to just, how do we keep this keep it kind of small and not too, but we'll figure it out. But
sure, very cool.
But I think we'll try to at least come up with something for next week, and then if we're here on Tuesday, we'll present the idea and we'll talk about it more. But
excellent. Okay, anybody else with comments, questions?
Can I say something?
Yes, please.
Okay, hi. I actually found something. I'm putting it in the chat. I think that might be a little bit interesting. So the European Commission actually recommended that member states now have to conduct special risk assessments when it comes to AI, when it's used for security, and the risk of military, of states and private sectors kind of combining their power in tech for AI. So what they're supposed to do is that the member states are supposed to conduct additional risk assessments in these areas. And they are also supposed to ask private sector parties to answer some questions. So I'm basically waiting to see how one could contribute here, but I think that would be a really interesting assessment to be part of. Yeah, and obviously it goes into the direction of human rights and trustworthy AI.
And how do you think we could be part of as an member of expert groups, or?
Yeah, I mean, so the thing is that it says that they have to take into account also basically private sector. Obviously, we're not the private sector, but I believe that they will either open up a new consultation, or they will somehow open up in the EU forums a way to contribute to that. I don't know if that will be in the way of a paper, or if it will be a consultation. This is very new, but I'm kind of hoping that they would open up one of these channels, and they're supposed to do so. So maybe there's a way of us contributing. Nothing has been published yet. But yeah, I will follow this. I think that could be really interesting to us.
Yeah, could you also send me the link by email, please?
Yes, of course.
Thank you. Very good. Yeah, if I would have more time, if the day would have more than 24 hours. That's really interesting, yeah. Okay. Any other comments, questions? So I could now briefly talk about one main research thread that our group is looking at. Where do I get the new page? Clear all drawings. So what I just had on my slide was this basic machine learning setting, but in practice, the data is not one big central data set on your computer or your Python distribution, but you have chunks of data flying around. Like these chunks of data could be created by people having smartphones. So there's a chunk of data generated by Alex, another chunk of data generated by Hans. So different people generate different data sets. And the question is, if I want to train a model, a personalized model, like, for example, a music recommendation model, then I often have too little training data because I can only listen to so and so many songs per day. But to train very powerful models, we would need more training data. And the key question is then, which other chunks of data should I also use for my training? So finding the right chunks of data. This is known in machine learning as active learning. Has been studied since the 80s or 90s. So I know a paper of the 90s. But there's now a new interest for using such methods or for having such methods for federated learning, personalized federated learning. So we train models for each person individually in a distributed fashion. So for example, I train my model using my smartphone, using the computational resources on my smartphone. But I want to somehow also benefit from the model training at other smartphones or the data sets that are used for model training at other smartphones. So how can we know which of these data sets is good to add? Are there any comments, any guesses, wild guesses from you?
I've been a lot in there. I've been talking a lot, but like less than wild guesses. Probably like something about just mathematics of like clustering and finding like this sort of like finding the statistically similarities in this group of data would be a starting point.
Yes, that's actually what we're working on, some form of clustering methods. This is very when you have the data in a nice format like feature vectors, numeric feature vectors in a Euclidean space, you can use clustering methods easily. So you can also analyze them to some extent using statistics. But in practice, if you think in the wild, machine learning in the wild, so you have some data set, some deep neural network, how do you know if adding this chunk of data points is good? What would be a very naive approach? Or could you think of a hands-on approach? Well, you could say, what is the goal of training a model? The goal of training a model is to have a trained model, to have the model parameters trained or tuned such that you can make good predictions. And how do you measure the quality of predictions of a trained model?
A loss.
A loss. On which set? On the training set? Where do you evaluate a trained model?
With the test data. With the
yes. So you have some test data set typically. This could be a part of your raw data, so test data. And you then see how well is the trained model doing. So what you could now do is you could say, okay, let's try it out. So let's try to merge this data set with my own data set, retrain the model, and see what happens on the validation or test set. And if the test error decreases, then it worked out. So let's keep it. You do the same with this and with any other chunk of data that comes along your way. So you try to add it to your training set, retrain the model, and see if it improves the test set error. And this is the idea. I have shared the paper with you on the chat. There's a recent paper. Where do I have it? It's called Metric Optimized Training. So this has been published, I think, at the Machine Learning Conference, ICML, a few years ago. Yeah, in 2019, so not too old. And the goal here is, so it's not, what I explained to you would be an extreme case where you choose either use this chunk of data or don't use it. But they make it more, they make a soft version of it. They say they want to find, where is it? They want to find weights, so sample weights between 0 and 1. So it's not that you either completely get rid of data sets or use it fully, but you can also use it only to 20% or so. So this is the effect of weights here. And they learn the weights for these chunks of data in order to minimize the validation error or maximize the accuracy on a validation or test set. So this is this argmax here. I mean, you can write down this principle, this idea in optimization problems, but it turns out this is typically, as I understood, a very complicated optimization problem. So this is not something you can solve easily with gradient descent in a robust manner, so that you are sure that this converges to the optimal sample weights. So what they do instead is then they resort to some kind of magic tool, I call them. It's a Gaussian process regression based optimization. So this is some tool that you then say, okay, I have an optimization problem which is difficult, so I now pull out this generic solver. So far so good. Why not? Why not? If the numerical results are promising, why not? At least it got accepted at this prestigious conference. And I was thinking now of using, instead of this Gaussian process regression, a naive, we could say stupid deep learning approach. So we learn to predict the best weights. So I feed in the candidate data that I'm not sure if it would be good to help my training. I feed this in as features to a deep neural network, and the output of the neural network is the weights. So how much should I use this chunk of data? How much should I use it? 10%? Should I not use it at all? So the weight would be 0, or should I use it completely? 100%. And I was just, so my idea is now to pitch this to you and see if anybody of you wants to pick up this cool idea and try it out on some numerical experiments. Is Amir here?
Yeah, I'm here.
Amir,
Hi.
how do you feel about this?
Yeah, it's a good idea, but firstly, for network federated learning that we have, I think we couldn't share the data because of the privacy thing that we have. So it's kind of useless in that settings, but generally it's a very good idea. So yeah.
Yes, so you're right. So if I go back to my sketch, so we cannot, so the candidate, this would be the candidate. So some other person has collected some music recommendations, and I'm not sure if I should use this data set also for my model. So we cannot share the raw data. That's the name of the game in federated learning. In federated learning, we want to only share some insights from our data, but we don't want to reveal everything about our data. So what could be done is to use some differentiable privacy methods. That is, perturb the data set a bit, like adding noise, with the hope that also the noisy chunk of data allows to tell if it would be a good idea to use that data set. So this would be my first idea to address this concern, this very valid concern of Amir. Okay. Yes, so that was what I wanted to share with you, what I'm currently thinking about and trying to get some first experiments running.
Yeah, I think I can do the experiments, but I'm at the end of the writing the paper.
Yes.
So I was thinking I finish it and then send the paper to you and then I start the next work.
Yes, that sounds very good. Yes. Okay. Yeah, I might then now try to pitch it personally to the group members, one after the other. Let's see if I find enthusiasm. Yes, but this could also be, as I remember correctly, one of you students who does this project was interested in the federated learning topic. So this could be related to the federated learning topic. But in the end, you are free to choose whatever you want for the content of the research project or for the application domain. Okay, if there are no other questions at this point or comments, I thank all of you for joining our meeting today. And yeah, wish you a nice week ahead. Do not hesitate to reach out to me by Slack or by email. Have a nice week. Bye.